Today we're going to start talking about the big bad trig ratios. Now, trig is something that has a very scary tone towards it, but today we're just doing trig ratios. So don't be too alarmed. You'll be able to tell your parents you did trig, but don't be too impressed with what we're going to do. We're going to take some baby steps today. So prepare yourself for this. You need a calculator ready to go as well. Before we can start talking about our trig ratios, what we first need to do is identify the three things we're going to be talking about. We're going to be talking about a hypotenuse, we're going to be talking about adjacent sides, and we're going to be talking about opposite sides. Well, the hypotenuse is very easy to locate because your right angle is always pointing right at it. Your right angle is always pointing at the hypotenuse. The hypotenuse is always the larger side. So in this case, our hypotenuse is either UV or VU. It does not matter. Either answer works. Next thing you see here is we are looking for opposite to angle J. Well, one way that you can always do this is if you name the triangle. In this case, the triangle is JOI. If you're looking for the one opposite of J, cover up the J, and that's what you got, OI. All right, so OI, and again, if you just draw, it's from the angle, it's the one side that it does not touch. That's the opposite of that. So the opposite of J is OI. And then the last one is adjacent. Adjacent is usually the one that gives people the most issue. Because technically there are two angles, two sides adjacent to angle N. But one of them has a higher rank than adjacent, and that's the hypotenuse. So we've got to make sure that we do not call the hypotenuse the adjacent side. The hypotenuse is the hypotenuse. So NJ is not our adjacent side, NS is. NS. NS, basically you could say adjacent is the non-hypotenuse side that touches the angle. So those are our three types: opposite, adjacent, and then of course the hypotenuse. So before we get into our trig ratios and setting those up, here's a nice little example for you. I will try to save this onto our home screen. Sine, these are pronounced sine, cosine, and tangent. Now the abbreviation for sine is SIN, abbreviation for cosine is COS, and the abbreviation for tan is TAN. So a lot of people want to call this sin, but it's not sin. Sin is an abbreviation for sine. It's a one-letter abbreviation. So what we have on sine, now you'll notice this as well, we have sine of multiple angles, but we never take a trig ratio from the right angle. The trig ratio has to be taken from an acute angle. So don't use the hypotenuse. So we've got to set our orientation first of all. So we are orienting from angle B on all of these. So as you can see, I have B marked there. Well, sine's ratio is the opposite side over the hypotenuse. Well, the opposite of B is 24, and the hypotenuse is 26. So that's why we have our ratio for sine of B is 24 over 26. On sine and cosine, your denominator should always be bigger because your denominator is always the hypotenuse. So just think about that as you go through. Example for cosine, again, we're just going from one angle today, but we could have gone from angle A, but we cannot go from angle C. So the cosine ratio is adjacent over hypotenuse. So adjacent to angle B is side CB, which is a measure of 10. And then the hypotenuse, of course, is the hypotenuse. So the trig ratio for cos of B is 5/13 when reduced. And then the last one is tangent, which is the only one that doesn't involve the hypotenuse. It is the opposite side over the adjacent side. So if we're looking at our trig ratio from angle B, because we could also go from angle A, opposite of angle B is 24, and the adjacent side is 10. So tangent would be 24 over 10. Now we're going to come up with a few acronyms that people use to help you memorize these. One of them is SOHCAHTOA. That's probably the most common one because it's S-O-H, sine, opposite over hypotenuse, CA, C-A-H, cosine is adjacent over hypotenuse, and then TOA, T-O-A. Tangent is opposite over adjacent. SOHCAHTOA. All right. Now they've got a shot here where you can put in your own acronym and see kind of what we're looking at here. If I can get it over there. So as we look at this, I'm going to show you a popular one. This is not mine. This is Miss Ozturk's original. She showed it with me. A lot of people memorize this. So if anybody gets in trouble with this one, it's hers, not mine. But if it helps you memorize, hers is some old hippie, some old hippie come a hoppin' trippin' on acid. It's a weird one, but a lot of people memorize it this way. SOHCAHTOA, some old hippie come a hoppin', trippin' on acid. Again, that's a Miss Ozturk original there. So if you like it, it's mine. If anybody gets in trouble, it's hers. All right, but you do need to memorize these trig ratios, and we will use those as we move forward. So here we are, finding the cosine of angle F. Now, I cannot do any of this until I set my orientation, and I am orienting my information based on F. Now, the thing you got to pay attention to is we cannot use the right angle as our starting point here, but this one they're telling me what to do. So we're looking for the cosine of angle F. Well, remember cosine has the ratio of, it's the it has the adjacent over the hypotenuse. Well, I know what the hypotenuse is, so we're going to write cos of F. The hypotenuse is 50. Well, the adjacent side is unknown as of now, but don't forget, we have a right triangle here. So we're looking for the side of a right triangle. This is where we're going to use Pythagorean's theorem to find the missing side. So the missing side, we'll just call it F. Leg squared plus leg squared equals the hypotenuse squared. So we have 48 squared plus x squared equals 50 squared. Well, 48 squared is 2304. And 50 squared is 2500. And then we just solve for x. So I will subtract the 2300 from both sides. 2304, excuse me. And I have an x squared equal to 196. And then to get the x by itself, I've got to take the square root. And we've been dealing with Pythagorean's theorem all year long, so this one should not come as a surprise to us. We should know how to do this. That's very important. We read our directions on these. So we find that this side is, in fact, 14. So the adjacent side is 14, so that is the numerator for my trig ratio. Now, the instructions say round the answer to the nearest hundred. So we're going to do that real quick. Cos of F equals 14 over 50 is approximately 0.28. Now, should have mentioned this before we got started. This is an example on your Delta Math. So go to your Delta Math. I'll remind you before we get to this point. But on Delta Math, your first example is 0.28. It's technically your fourth example, but You'll see. So this one's asking us to find tangent from angle J. So again, we've got to get ourselves oriented. The natural instinct is to want to come down here and use the one that's on the bottom, just because a lot of times when we teachers give you examples, that's the one we do. But remember, we have to be oriented from somewhere, and in this case, we're oriented from J. And it's also a tangent. So that's the TOA. Opposite over adjacent. Well, the opposite side from angle J is given to us. It is 16. But we do not have the adjacent side. The adjacent side being this side right here. So we're going to use Pythagorean's theorem on this. So if we're using Pythagorean's theorem, remember it's leg squared plus leg squared equals the hypotenuse squared. So 16 squared plus the unknown amount squared equals 34 squared. So 34 squared is 1156. 16 squared is 256. So we're here. Solving for x, we need to subtract 256. X squared equals 900. So if x squared equals 900, we take the square root, and x equals 30. So this missing side, which was our adjacent side, is 30. Again, make sure we read our instructions. Our directions say write in the simplest form. Well, that answer is correct. Your calculator will know that's correct, but in simplest form, 16 over 30, they both are even numbers. So we can factor out a 2, which would reduce this down to 8 over 15. So tangent of J equals 8 over 15. So hopefully we're not too terrified of our trig as of now. We're going to add some radicals in here, but I just want you guys to stay calm as we work through these. So in this one, we're asked to find the exact value of cosine A. So, and leave it in simplest radical form. So if we're finding the cosine of A, what we have here, cosine again, and again, first we need to identify or orient ourselves. We are going from angle A. So cosine is adjacent which is 1, over the hypotenuse, which is the square root of 26. Now at this point, if you're using my bump and keep method, this works out really nicely for us because we know we can bump the square root of 26 up there to join the 1, and we can keep the radicand 26. So that's what we have as a solution. For those of you, I'll do the good teacher thing and show you the correct way we're supposed to do this. We're multiply times the square root of 26 times the square root of 26. And then 26 times 26 would be square root of 26 over the square root of 676, excuse me, which is 26. So if you want to do it the more responsible way, you can do that. Now this 1 is not a problem. I can't imagine Delta Math is going to count that wrong. You do get multiple attempts, so if somebody wants to try their luck, they can, but they should count this correct because it is a correct answer. 2 more examples here. This one is another tangent. I have not intentionally avoided sine. There's nothing different about sine. It's just a different orientation. So we have from angle A, and we have a tangent. So we're looking for the tangent of angle A. Well, tangent is opposite over adjacent. So our tangent is going to be the opposite side from angle A, which is 5, over the adjacent side, which is square root 75. All right, we could reduce our radical here, but I'm going to leave it alone for just a moment here, and I'm actually going to bump and keep this up towards the top. There's about half a dozen ways you could do this and still get a correct answer. So I'm going to bump the square root of 75 up to join the 5, and then I have to keep a 75 when I do that. All right, I'm not going to reduce anything just yet. Let's see. Actually, I will. Let's go ahead and reduce this 5 and the 75. Those both have a common term, so we're going to reduce that down, and this actually becomes 15. So here's where we are now. Tangent of A equals square root of 75 over 15. Remember, those don't reduce. That's a radical, and the other one is not. So if you want to use your calculator like I've shown you, remember, we can go y equals 75 divided by x squared to see how this radical would reduce. Another option, you might have had an Algebra 1 teacher show you this, and that's the prime factors of 75. Well, that would be 25 times 3, which breaks down to, need a little more space than that. We'll do it here in a race. So breaks down to 25 times 3, which breaks down to 5 times 5. Anything that pairs out gets out. So the square root of 75 can be rewritten as 5 square root 3. We'll highlight that so we don't lose that in the mix. This is this because of this. Now we've got another thing happening here because we now have 5 over 15, which also reduces. So we finally get down to an answer here, and our answer is tangent of angle A equals the square root of 3 over 3, because remember, when I factor a 5 from 15, it is 3. So that was a good bit of work there. Nothing incredibly hard, maybe a little unfamiliar with a few things, but there we have it. Guys, if you're struggling with the radicals, let me know. The ratios, though, we should set these up nice and easy. They all follow the same little principle here. And then the last one has no graph. I created my own triangle beforehand, but just make yourself a triangle. You can name it what you want. It does not have to be to scale. If you're interested in that, you could sit here and see, okay, BA is my largest side, and then BC is my second. So if you wanted it to be perfect, you could set it up this way. So B is part of the two largest, so that would be this one right here. A is part of the largest, and C is over here. It really does not matter because we're going to look at the numbers, but if you want it to look right, you can take the time to make it do this. And then 77. And it tells us that this is a right triangle by saying that C is 90 degrees. And then it asks us, what is the tangent of angle A? Well, there's angle A. So tangent again, opposite over adjacent. Tangent of angle A, opposite over adjacent. Opposite of angle A is 77. and adjacent to angle A is 36. So later on, we'll learn what we're supposed to do with these amounts. And I've got to read my instructions. It says round to the nearest hundredths. But what we'll learn is we can use these trig ratios to calculate our angles. So what this ends up being is approximately 2.1389, which is going to, again, make sure you use your approximation sign. This is our way of letting everybody know that, hey, this is not an exact answer, but it's the best I got. 2.14 when we round to the hundredths place. All right, so I've created for you a delta math. One of those has a time thing. Please don't get frustrated. Some people panic because it's a time thing, but you have 2 minutes. You should be able to take your time, but it's going to be fun for some of you. You can set yourself a goal, and let's see who can finish theirs the fastest. Now, pay attention to how many you have correct, because it keeps letting you do them once you get past your number 10. The timer does stop, but you could sit there doing it all day, so pay attention. All right, good luck, everybody.